Hello everyone, my name is Neil Hepburn and this is the Astronomy Research Project, Blue Supergiant Star Born in the Wild. Our first slide, we have images of the blue supergiant star. In April of 2013, Dr. Yuichi Oyama and Dr. Ananda Hotta discovered a blue supergiant star located far beyond our Milky Way galaxy in the constellation Virgo. The constellation Virgo is located in the far upper right corner, and the images shown represent how large the blue supergiant is compared to our own Sun. And if you see, the blue supergiant is much larger than the Sun. Over 55 million years ago, the blue supergiant star emerged in a chaotic environment. The star emerged from a long trail of gas removed from the galaxy IC 3418 as it spread rapidly into the Virgo cluster and interacted with hot plasma, the surrounding intercluster medium. And below, we actually have a picture of the blue supergiant in a spectroscopic context. Now we have instruments that were used. Instruments used were the Subaru telescope, the Canada-France-Hawaii telescope, and NASA's Galaxy Evolution Explorer, also known as the GALEX. With these instruments, it was possible to view the star's formation in a spectroscopic context. Now, onto the capabilities of the telescope. The GALEX is an orbiting UV space telescope. It can see light wavelengths from 135 nanometers to 280 nanometers. The Canada-France-Hawaii telescope is a prime focus Cassegrain configuration with a usable aperture diameter of 3.58. And the Subaru telescope is a reflecting Cassegrain telescope, the diameter of 8.3 meters. This provides a wider field of view. And noting that the Canada-France-Hawaii telescope and the Subaru telescope are both located in Mauna Kea, Hawaii. On to other recent discoveries. Through this type of research, astronomers found an odd-looking spiral galaxy, shown in the upper left-hand corner of this image, that plows through the cluster after being accelerated to at least 3.5 million kilometers to the hour by the enormous combined gravity of the cluster's dark matter, hot gas, and hundreds of galaxies. As it speeds through, it rams into the hot gas that permeates the cluster. Its gas and stars pulled away by the gravitational tidal forces exerted by the cluster, just as the forces exerted by our moon and sun pull the Earth's oceans. Now we have other events. The blue supergiant star is quite possibly the farthest star in a spectroscopic observation. In the future, with the construction of the 30-meter telescope, there is more potential for stellar spectroscopy. And as you can see, these are all pictures of what the future 30-meter telescope will look like. And through better technology, more observations will be possible. And last but not least, here's a HR diagram to the right. And through this study, it was very interesting to see how the material pertains to what we have studied in class. It will be interesting what stars astronomers will find in the future. With new technology and current research, the limits are infinite. And here is our quiz. Number 1. On the HR diagram, What spectral class is a blue supergiant star? Number 2. In what constellation did the blue supergiant form? 3. What type of observation is this study? This time I'd like to thank you all for listening to my presentation, and I hope you're informed of the new blue supergiant star. Thank you.